Hello, today we're going to talk about reaction energy profiles. Okay, so here's a really basic energy profile. The y-axis will have your energy, and then your x-axis is like the reaction progress. You could say time, but it's not typically tracked or measured over time. So this is a more vague terminology for it. Because of that, sometimes this is also called a reaction coordinate diagram instead of an energy profile. But you'll always see the reactants on the left and products on the right, and then there will always be the activation energy hump. And then present at the top is either the transition state or the activated complex. It's the same thing, just two different words for it. And that is the highest energy point for the reaction. Okay, so endothermic and exothermic. An exothermic reaction, the reactants will be at a higher energy level than the products. So that means that there is a difference in energy here. So the difference between the reactants and the products, that is called the delta H, or the enthalpy. And we'll get more in depth with enthalpy later on. But right now, that's the overall net change in energy. Okay. And for an exothermic reaction, since it's decreasing, delta H is negative, decreasing, going down, and so that energy must be released to the surroundings. Now, in an endothermic reaction, the reactants are lower than the products. And again, you'll still have a net energy change, and it's still called delta H. But in an endothermic reaction, it's a positive value because it's increasing over time. So energy is being taken in from the surroundings, or it's being absorbed. Energy is being absorbed. So the way that I remember it is that endo is kind of like enter, so he is entering to the reaction. Exothermic is kind of like exit, so he is exiting the reaction. Okay, so then the other thing that's really common with energy profile diagrams is that they'll ask you to plot two curves, one with the original reaction and then one with a catalyzed reaction. Now, a catalyst will speed up a reaction by lowering the activation energy. Catalysts do not change the level of energy of the reactants or the level of energy of the products. So this dotted line here is the normal reaction. The green line here is the catalyzed reaction. So notice how the energy for the normal reaction is a much larger magnitude than the energy for the catalyzed reaction. You should also notice that this is an exothermic reaction because the reactants are at a higher energy than the products. And so here we have the delta E. This diagram uses delta E, but it's also called delta H. So that's the change in energy for this reaction, and since it's exothermic, it will be negative. But notice how that this value is not changed by the catalyst at all. The catalyst only changes the activation energy.